Radians is a unit of measure for angles. To understand radians, we're going to look at a circle. If we look at one radius length, so this radius length here would be the same going in any direction. If I take that length and go around this circle, so that's about 1 radius. This angle right here would be equivalent to 1 radian. So 1 radian is when the arc length equals the radius. So if I continue that pattern around, if I go another radius length around, this would be 2 radians. If I go another radius length around, it's just shy from being halfway around. This is at 3 radians. Another radius length, 4 radians. Another radius length goes right into the 4th quadrant. And one more around. It doesn't quite go all the way around. This would be at 6. So if you go all the way around, this really connects with their circumference. And that would be 2 pi, which would be about 6.28 radians, completely around. So if I look at the opposite end, at halfway around, I'm at 3.14 radians. So we're always talking about with radians is a comparison of our arc length and our radius. Another way to look at radians, instead of being a decimal, is to look at the value in terms of pi. So pi would always be in our answer. So in this circle, there are 8 wedges in here. If I look at this arc length here, this arc length is shorter than the radius. So that one piece, that angle of it is not even quite 1 radian. It's less than 1 radian. So we're going to write this in terms of pi. In a full rotation, there are 2 pi radians. If we're thinking of decimals, that'd be 6.28. But we're going to do this in terms of pi. So in the full rotation, there's 2 pi. So if this full rotation is divided into 8 equal pieces, this one piece here, so this one piece will be equivalent to 2 pi divided by 8. If we simplify it, it would just be pi over 4, or you can think of it as 1/4 pi. So that one angle will be representative of pi over 4. So 2 of these would be 2 pi over 4. 3 of these would be 3 pi over 4. 4 of these would be 4 pi over 4, which would simplify down to pi. And we could continue on to 5 pi over 4 and so on. We could go around even more than one rotation, but still, when we look at this, our denominator still is constant and has that 4 in it. So we could have a positive or negative rotation. And we know here that when we have this pi over 4, really the 4 here is going to represent how many pieces we're splitting half of the rotation into. So half this rotation, this half, is pi radians. So when I see that denominator of 4, that means I'm splitting the top into 4 equal sections. And then I'm also splitting the bottom into 4 equal sections. Now I have a circle that's divided into 6 equal parts. So if I look at how big just one of these parts are, I have a total of 2 pi, and I divide it by 6. This simplifies down to pi over 3. I also notice, because I have 3 sections in the top, so just 1/2 of it, or I could say 3 sections in the bottom, that 3 is going to connect with my denominator. So for instance, if I'm looking at sketching a graph that would be 5 pi over 3, I would want, when I'm graphing this, I would divide each half into 3 equal parts. So I'm not using my vertical axis in here. So if I count this, I'm going 1 part, 2 parts, 3 parts, 4 parts, and 5 parts. So my x-axis is including those parts, but not the y-axis. This would represent a 5 pi over 3.